Chapter 3 and Chapter 4 test. We started off with 3.1 with the product rule and quotient rule. So let's do an example using those. So first question is if we want to find a tangent line for function y equals x minus 1 to the 5th times x plus 3 to the 2nd at point 2, 25. So if we want to write a tangent line, we know we need three things: an x and a y, which were given, and a slope. We find slope through the derivative, right? So derivative of this equation, well, an x quantity times an x quantity, that's a product rule. So f is the first portion, the x minus 1 to the 5th. G is the second portion, the x plus 3 to the 2nd. So f prime is, bring the power down, 5, leave the inside alone, to the 4th, times the derivative of the inside. The inside here is x minus 1, so the derivative is just 1. G prime is, again, start out by bringing the power down, 2, x plus 3 to the 1st, times the derivative of the inside, which is, again, just 1. Now we use the product rule formula. We need to remember product rule formula is f prime of x times g of x plus g prime of x times f of x. So, using things that we found, right, f and g and f prime and g prime, we can plug in. So f prime times g, 5 x minus 1 to the 4th times x plus 3 squared plus g prime times f. 2 x plus 3 times x minus 1 to the 5th. So then what we can do is to finish finding the slope. Well, we found the derivative. Now we actually need to find the value of the slope. Well, that just means we plug in the point information, right? So all we have are x's. So we plug in just the x value of 2. Plug it in for every single x. So then y prime, or m now, is 5. 2 minus 1 is 1 to the 4th times 2 plus 3 squared plus 2, 2 plus 3, and then 2 minus 1 is 1 to the 5th. So our slope is then, well, 1 to the 4th is 1, so 5 times 2 plus 3 is 5, squared is 25, plus 2 times 2 plus 3 is 5, so 2 times 5 is 10. 1 to the 5th is 1, so just 10. So then our slope is 5 times 25, which is 125 plus 10, or 135. So now we have all the information we need to write a tangent line. When we use, for tangent lines, point-slope formula. So y minus the y value of 25 equals the slope of 135, x minus the x value of 2. This is our tangent line. Next problem will be about taking the derivative of y equals x plus 2 over x minus 7 to the 9th. Now we should all recognize this as a quotient rule overall once we simplify, because we have an x portion divided by another x portion. Because there's an x in both the numerator and the denominator, that's why we have to use this rule. So because it's division to an exponent, we can almost distribute that power to both the top and the bottom. So just algebra simplification so far is equal to x plus 2 to the 9th power over minus 7 to the 9th power. Now it's set up so that we can go directly into the quotient rule. So f is equal to x plus 2 to the 9th. G is equal to x minus 7 to the 9th. And f prime is equal to now, taking the 9 down, 9x plus 2 to the 8th times the derivative of the inside of 1. G prime is equal to, bringing the 9 down, leaving the inside alone, subtracting 1, times the derivative of the inside. So now we can go into the quotient rule format. Remember, the quotient rule is f prime of x times g of x minus, for quotient rule, g prime of x, f of x, over g of x squared. Okay, so start out still f prime g. So we have 9x plus 2 to the 8th times x minus 7 to the 9th minus g prime f, 9x minus 7 to the 8th times x plus 2 to the 9th over g squared. Now g is already to a power. When we have a power, then we square it overall. That means we multiply the exponents, right? That's what we learned in 4.1 with multiple layers of exponents. So then this is really x minus 7 to the 9 times 2, or 18. Okay? Now, we could leave it here, or we could simplify it. Some of the simplifications that we need to do sometimes, right, for some of the problems that ask for specific versions, okay, would be simplifications that we could do here. So I'm going to do them out so that we can get that practice for those questions that are multiple choice instead of fill in the blank. So on this, we need to notice what we can factor. So on the numerator, both pieces here have a 9, so we can factor out a 9. Then both pieces have an x plus 2. It's different powers, but they both have x plus 2. So we need to find the lowest power. So x plus 2 to the 8th here, and x plus 2 to the 9th there. So that means we can only take out 8 of them. Then both of them have an x minus 7. Again, different powers. So this one has 9 of them, this one has 8. So again, we can take out 8, the smallest power. Now we need to think about what's left. What's left, we find that through essentially factorization. Factorization is essentially just division. So if we divide this by this, then we get what's left. That's what our answer is inside of this. So we took out the 9, we took out all 8 of these, we took out 8 of these, so that means we have 1 left. So we have an x minus 7 left, minus the next thing that we have left. So again, we took out the 9, we took out 8 of these, and 8 of these, meaning we have 1 of these left. So an x plus 2. Now we do need these parentheses because of this minus in between. If we don't write the parentheses, then there will be incorrect simplification here. So then this is over x minus 7 to the 18th power. So then we have 9, still x plus 2 to the 8th, and we have an x minus 7 to the 8th over x minus 7 to the 18th. So then we can cancel. So we have 8 here, and take away 8 here to leave with 10. So then, simplifying inside the brackets, we have x minus 7 minus x plus 2, or just x minus 7 minus x minus 2, okay? Over x minus 7 to the 10th. So y prime is equal to 9x plus 2 to the 8th. Combining like terms, the x's cancel. Minus 7 minus 2 is minus 9 over x minus 7 to the 10th. one more simplification. 9 and negative 9 with multiplication, here is just negative 81 x plus 2 to the 8th over x minus 7 to the 10th. That would be our final answer for this problem. Okay, so then that moves us on to the next section, 3.2. 3.2, we talked about the chain rule. So the problem that we'll do for this is we're asked to find d dx of f of g of x, where f of x is given as the square root of x and g of x is given as x squared plus 5. Now again, just like we learned in class, there are two different ways of doing this problem. We can substitute first and then take the derivative, or take the derivative of each piece, multiply them, and substitute. For this one, it's much simpler to just do the substitution first. So, f of g of x is equal to the square root of x squared plus 5, okay, because we just plugged x squared plus 5 into the square root, because that's where x was. We replaced x with g of x. So then, we just take the derivative. But to do that, we need to rewrite it first, because this is not in simplest form yet to be able to take the derivative. So we need to rewrite it as x squared plus 5 to the positive 1/2 power. Now we can take the derivative. So then the derivative here, I'm just going to write the f prime, okay, is 1/2, keep the inside the same, subtract 1 from the exponent, so negative 1/2, times the derivative of the inside. X squared is 2x, plus 5 is 0, so then we just have times 2x. This is not our final answer though, because we have 1/2 and 2x. The 1/2 and the 2 just cancel, okay? So then, don't leave the x over there, don't forget him, bring him up front. So our derivative is just x times x squared plus 5 to the negative 1/2. That is an okay format to leave it in. Next is another problem like this one, another chain rule type. So if we are given that we need to find dy dt of t equals 3, when we have y equals x plus 3 over x minus 3, then x is equal to t squared over 4. Now, we did the other one, the substitution method. So let's do this one, the separate multiply then substitute method. So we have both versions. So that means we need to take the derivative of each of them separately first. So taking the derivative of the y is a quotient rule. So the f will be the numerator, the x plus 3. G is the denominator, the x minus 3. So then f prime is equal to 1. G prime is also equal to 1. Pretty basic, simple derivatives here. So then y prime is equal to f prime times g. So 1 times x minus 3 is x minus 3, minus, because it's quotient rule, g prime times f. So because this is a minus here, we must use parentheses around the x plus 3. Times 1, it again doesn't change anything, over g squared. So x minus 3 squared. So let's simplify this before we go to the other piece. X minus 3 minus x plus 3. So that's x minus x. X is cancel. Negative 3 minus 3 is negative 6 over x minus 3 squared. That's y prime. So then we need to find the derivative of the other piece, the x equals t squared over 4. So we're just finding x prime. When we do this, we recognize that there's a variable only in the numerator. So we can kind of think about this like 1/4 t squared. Okay? So then taking the derivative here, we multiply the 2 down. 2 times 1/4 is 2/4, or simplifying that is 1/2 t. Okay? So then what we do here is we multiply our two derivatives together. So y prime times x prime is equal to negative 6 over x minus 3 squared times 1/2 t. But then we have the issue that we have different variables. We have an x and we have a t. Well, we have the fact that x is equal to t squared over 4. So that's what we need to plug in here, okay? Because t here, right, because it's on the bottom and that's what we have a value for, is our actual variable that they want us to end up with. So this is equal to negative 6 over, well, the x is t squared over 4 minus 3 squared times 1/2 t. Because it's all t's now, this is the actual derivative format. However, we wouldn't need to simplify this any because we're just going to plug in a value of 3 for t. So just go ahead and plug it in before you try to simplify any. So we have negative 6 over, t is 3, so 3 squared is 9, so 9/4 minus 3 squared times 1/2 times 3. So then, simplifying this, we could put it in a calculator. That would be okay. If we want to simplify this though, 1/2, this 1/2 here, can be multiplied times the 6. Even though it's a fraction times a fraction, we can take all of it up into the numerator like that. So 1/2 of 6 is 3, right? So then we would have negative 3 times 3, which is negative 9 over, keep the 9/4 the same, then we need to think about 3 written as a common denominator. Well, then we need to make it over 4. So 3 times 4 is 12 over 4 then, and then still squared, equals negative 9 over 9 minus 12 is negative 3. So we have negative 3/4 squared. That will give us negative 9 over negative 3 squared is positive 9. 4 squared is 16. We have a fraction inside of a fraction now, okay? So that means we have negative 9 times the reciprocal of the bottom fraction. So 16 over 9. These 9's cancel. So then our final answer is then just negative 16. Okay? So then we can move on to the next section. That will be implicit differentiation and related rates. So implicit is when we have y involved, right? It's not just y equals anymore. We could have problems like y to the 8th minus 9x to the 5th equals 5x. So, taking the derivative here, we start out every term the same way, just using our regular derivative rules. However, we don't treat y exactly the same, right? The derivative of y to the 8th is 8 y to the 7th times the derivative of the inside, or minus, now we treat x still the same, because this is not a related rate, just an implicit differentiation problem. X is still a variable. So multiply the 5 down, 9 times 5 is 45, x to the, take away 1, so fourth equals 5x, derivative is 5. So now we solve for y prime, or dy dx if they call it in the program. So we're solving for this, meaning add this over to the other side. So 8y to the 7th, y prime is equal to 5 plus 45x to the 4th. Then divide by 8y to the 7th. So y prime is equal to 5 plus 45x to the 4th over 8y to the 7th. Okay? That's our answer. That's it. We can, from this point, find a slope value by plugging in both an x and a y value. We could find a tangent line with given a specific point, find the slope, write the tangent line. Okay? So from this point, we can go in several different directions with it, depending on what they ask of us. So the next problem would be a related rate. One that's usually shown is the ladder problem. So we have a building with a ladder leaning against it. Okay? So if this is happening, that means we need to know a little bit about this situation, right? We have a 10-foot ladder. We know this distance, the bottom of the ladder to the bottom of the building is x. The distance here, the top of the ladder to the bottom of the building is y. So first we need to write out an equation relating all these together. We will assume this is a right angle, meaning the building is straight up and down, not crooked. Okay? So this is a right triangle, meaning we can use Pythagorean theorem. So hypotenuse squared equals the sum of the legs squared. So x squared plus y squared. So that's our formula. That's how we relate these together. So then we need to know, okay, what's the next part of the question? Next, after this, they would ask us for what if we're pulling the bottom of the ladder away from the building, meaning we're enlarging x, well, then the top of the ladder is sliding down the building, meaning y is getting smaller, okay? So if they tell us that x equals 6, and then the x prime, or they will call it dx dt, is 4, find y prime, or dy dt, okay? Because all of these depend on time. When do we look at the ladder? What position is it in? So, to find this though, we need one other piece of information. We have x and x prime. We were not, however, given y, but using our formula, we can solve for it. So we just need to plug in 6 for x. So 10 squared is 100 equals 6 squared is 36 plus y squared. Solve for y squared. Y squared is equal to 100 minus 36 is 64. So then y would be equal to plus or minus 8. But y is a distance on a building. Negative 8 doesn't make any sense. So it's invalid. We only use the positive 8. So then we have x, x prime, y, and we want to know y prime. So if we want to know y prime, meaning we need to find the derivative. So the derivative of 10 squared, this is not a power rule, because this does not have a variable in it, or a function of a variable in it, okay? So this is just a number. This is 100. The derivative of 100 is 0. Even if it's written a different way, it's still 0. So then the derivative of x squared, remember this is related rates. These x and y's are about t. So it's not just 2x, it's 2x times x prime, plus not just 2y, but 2y times y prime. Okay, so then we can go ahead and plug in. So 0 is equal to 2 times x, so 2 times 6 times x prime, so 4 plus 2 times y, or 8, y prime. So 0 is equal to 2 times 4 is 8, times 6 is 48, plus 2 times 8 is 16, y squared, or y prime. Solve for y prime. So subtract the 48 over. 16y prime is equal to negative 48 divided by 16. So y prime is equal to negative 48 over 16, or negative 3. Meaning that y is decreasing at a rate of 3 feet per second maybe, or feet per minute. Okay? That would be the answer to this problem. So let's go ahead and move on to chapter 4. Chapter 4, we remember, started out with a section of algebra on exponent rules. So the first problem that we'll do is if we're given 5 to the power of negative 6 minus x is equal to 25. So if we want to solve this for x, meaning we need to get the bases the same first. So 5 to the negative 6 minus x doesn't change. 25 can be rewritten as 5 squared. Now, same base means the exponents must be the same. So we set them equal to each other. Solve for x. So negative x equals, add 6 over, 2 and 6 is 8. Change the signs. So x is equal to negative 8. That's our answer. We can plug it in and check. Minus negative 8 is plus. Negative 6 plus 8 is 2. 5 squared is 25. So it does work. Okay, so then next, if we have given e to the x cubed minus 8x plus 3. Moving on to section 4.2/4.3. We want to take the derivative of this. So we look at first the exponent. What is the derivative of the exponent? The derivative of x cubed is 3x squared. Minus 8x is minus 8, plus 3 is 0. It must be in parentheses because this quantity is being multiplied down times the coefficient. Okay, the coefficient here is a 1, so it's not written, but the entire thing is multiplied down times the rest of the things, so it has to be in parentheses. Times e to the same power. The e to the power, e to the exponent, never changes. It's always written the same way for the answer. Okay, so then that would be our answer. That would be the derivative. So now we want to find possible minimums and maximums. If we're given that f of x is equal to 6 plus x times e to the negative 4x. So, finding minimums and maximums. Going back to chapter 2. We know mins and maxes are found by taking the derivative and setting it equal to 0. So, we need to take the derivative of this. We notice here, this is an x quantity times another x quantity. This is a product rule. So f is equal to 6 plus x. G is equal to e to the negative 4x. F prime, derivative of 6 is 0. Derivative of plus x is 1. G prime is equal to the derivative of e to the negative 4x. we look at the exponent. Derivative of negative 4x is negative 4. Then rewrite the e to the negative 4x. That's g prime. Now this was a product rule, so we go into the product rule format. So f prime of x is equal to f prime times g. So 1 times g is just g, e to the negative 4x, plus, because product rule, g prime times f. So negative 4e to the negative 4x, you can write that in parentheses. It doesn't need to be, but it doesn't hurt anything. Times, now this does need to be in parentheses, 6 plus x, again because it's a quantity. So we're finding min max. We found the derivative. We need to set this equal to 0. To do that, now to simplify and solve for x, we need to factor. We see that there's an e to the negative 4x in common in both of these terms. So that means we can factor it out. So e to the negative 4x times what's left. Well, again, it's like division. If we divided by e to the negative 4x here, we would be left with 1, where its coefficient is 1. Minus, the plus and a minus just make a minus, 4, so we didn't take out the 4. We took out the e to the negative 4x, then we're left with 6 plus x still, equaling 0. We need to simplify this inside. So we have e to the negative 4x times 1, multiply the negative 4 through, so negative 4 times 6 is negative 24, negative 4 times x is minus 4x, is equal to 0. Simplify the inside again. E to the negative 4x times 1 minus 24 is negative 23, minus 4x is equal to 0. Now, two factors equal 0, each of them equals 0. So we have e to the negative 4x equals 0, and negative 23 minus 4x is equal to 0. So then we need to think about these for a second. E to a power. There is no exponent that could ever make something equal 0 if it didn't already equal 0, okay? So that means there's no x value here that will make e to a power equal 0. So this one is not valid. We won't get an answer from that part. But we will get an answer from this part. We need to solve for x. Add the 23 over, so negative 4x equals positive 23, divide by negative 4. So x is equal to 23 over negative 4. So that means this is our x value. Okay, that is our only possible x value as well. If we needed to find the point, we would just take this x value and plug it in to the original function, right? That would give us the y value, right? So then, next, we're moving on to 4.4, the last section. In that section, we need to be able to convert using e's and ln's and solving or simplifying, finding x. Okay, so if we're given a problem, e to the 3x minus 4 is equal to 6. We need to solve for x. In this setup, e is already on its own. So we don't need to do any simplification here first. We can go ahead and use the natural log to get rid of the e. So we take the natural log of both sides. The natural log and e cancel each other because they're inverses. Then 3x minus 4 drops down. Equals the natural log of 6. Okay? So then finish solving for x. But remember, natural log of 6 is one quantity. It's 6 is inside the natural log, okay? So we can't get to the 6. We add the 4 over. We have 3x equals 4 plus natural log of 6. Divide by 3, so x is equal to 4 plus the natural log of 6, all divided by 3. That 3 does not go into the 6. This would be our final answer. Okay? Alright, so this is the final question that I have. If you have any questions, don't forget to come to class on Tuesday. I have a sub already set up that you can ask questions. Bring questions from maybe the review homework or any of the homework sections that are still out and due. Don't forget, so we have 4.2, 4.3, and 4.4 due on Tuesday, and the review section of homework also due Tuesday night. The test is on sections 3.1 to 4.4. Okay? If you want to send me any emails, remember to try to be concise and not to please send multiple at a time. Alright? Have a good weekend.